Thanks all. Yep, so I'll skim quickly over HLB vectors. I believe you'll have the presentation afterwards, so don't worry about the details, and the references you can find them later. So jumping straight into it, if I can. Just talking generally about psyllids first. So psyllids are a group of small insects, 1 to 6 millimeters. They're related to aphids, scale and whiteflies. So similarly, they have rapid reproduction. They're sap feeders, and in this case, they're pretty host specific, usually one or a few related plants. They excrete sugary honeydew. They transmit a few significant plant diseases. In HLB case, it's a bacteria, and the picture there shows another psyllid spreading another Librobacter, so that's tomato potato psyllid and zebra chip disease, which you might be familiar with. But the two psyllids we'll talk about are the vectors of HLB. So one of those is the Asian citrus psyllid. So again, a very small insect, poor flyers. They often don't fly more than 100 meters under their own steam, but wind will certainly support them further. They like lower altitude environments, and they've got a pretty quick life cycle, depending on temperature. Can be anything from just over 2 weeks to about 6 weeks to get from egg to adult, and there's 5 nymphal stages in between there. All those stages live on new flush. Only the adults will survive on older leaves. So the citrus flush is quite important. That's often around spring or autumn, but that'll depend on the climate. High temperatures and rain also promote that flush. So for Asian citrus psyllid, they like it hot. 25 to 28 degrees is ideal, and that warmer temperatures will get them more active and flying further. There's a typical stance of an adult there on the left, and you can see nymphs, and they produce a lot of waxy excretions, which are quite visible often. So realise this is quite small, and looking at very close up, it's at the new flush, but is visible to the naked eye. And on the right, you can see what happens when you get heavy infestation. You get distorting of those leaves. So where is it? On the left, we've got a map of where Asian citrus psyllid is currently recorded. You can see that, you can probably see my pointer. So it's been known from around China for over 100 years, possibly indigenous to that area, but it has spread over time. So back in 1927, it was recorded in Indonesia, Brazil in the 40s, USA not until 1998, and very recently in Africa. On the right, I've got that map that Cherie showed, which is the Asiatic bacterium. And that similarly, although the bacterium wasn't known, the disease was known for over 100 years in China. And then much more recently, it's been spreading around the world. Where could they establish? So there's different models of predicting where they could end up, but in the orange you can see where a couple of models agree that it's very likely they'll cover all of that, and yellow shows a couple of maps that a couple of extra areas that one of the model agrees to. Transmission. So Cherie's already mentioned this. There's differences in some of the studies of exactly how long it takes, but the point is that they need a significant amount of time to feed in order to both acquire and transmit that disease. Nymphs actually acquire it more readily than adults, and transmission by the adults is more efficient if they've acquired it as a nymph. They have got that latent period, 17 days, between picking it up and being able to transmit it. And it's persistent and multiplying once it's in the insect. So they transmit it for quite some time, up to 35 days after that latent period. Here's the second vector. This is African citrus psyllid. And you can see on the left, the picture A, there's bumps on the leaves are quite distinctive on this new flush. If you look close up, there are actually depressions underneath the leaf, and that's where the nymphs will sit and feed. And you can see here heavy egg laying, and that's an adult there of the African citrus psyllid. There's a close-up of some nymphs. The frilly edges are a bit different to the Asian citrus psyllid. So this is actually a different family to the Asian citrus psyllid. So they're not really closely related, the two psyllids, even though they spread very similar bacteria. The adults are a little bit smaller at 2 to 2.5 millimeters. They can produce up to 2,000 eggs from one female. So obviously those numbers can just explode when conditions are right. And like Asian citrus psyllid, they're mostly wind dispersed or via movement of plant material. African citrus psyllid is adapted to cooler and more humid environments, and they like higher altitude as well. And trials indicate that this African citrus psyllid vectors the Asiatic bacterium as effectively as the Asian citrus psyllid. So that's of concern when you start looking at where it is. This is one that has been known for over 100 years in South Africa. So on the left, we've got the insect described in Eritrea around 1918. Not until 74, it was found in Saudi Arabia. Concerning is that it's popped up in Canary Islands in 2002 and Spain and Portugal around 2014. On the right, you've got the African bacterium. So currently still pretty much in Africa, but has been spreading. And as we said, there's also that Asian bacterium that could be spread by this same psyllid. So this psyllid already being up in the Mediterranean, the main citrus growing parts of Europe, means that there's a vector ready to spread it in that region as well. So looking at where the African citrus greening could end up, there's modelling showing that it can be pretty much across the globe. And if you look at the fine detail, so for example, things like New Guinea, that's actually the highlands, they're mountainous areas. So where Asian citrus psyllid might not do well, African citrus psyllid and the African bacterium could do better. So the threats, obviously there's that feeding damage when you start getting large numbers of the psyllids and you get heavy infestations will cause sooty mold. But obviously the HLB transmission is the main risk, and especially that combination of two vectors and bacteria, they'll complement each other and can cover a lot further geography. So human-assisted dispersal is a great threat, and there has been a study showing that African citrus psyllids survive for 11 days on picked fruit. Market access and trade obviously is impacted with the pests and diseases themselves, but also pesticide contamination is an issue because people are using a lot of pesticides for these, and that then brings in environmental and public health issues. For monitoring these psyllids, the Asian citrus psyllid feeds on all citrus, but it prefers Morea. So the mock orange jasmine, Morea paniculata, and also the curry leaf are quite attractive to it. So they're a good place to be monitoring for the psyllids. And the methods used is focusing on that new flush. So visual surveillance of the flush, sweep netting of the flush, beating of the foliage, but also sticky traps. So you can use yellow sticky traps are attractive. And there's actually ones that are slightly more green that are more attractive to Asian citrus psyllid. And nowadays you can get lures for those. So in Australia, we're lucky, along with the Mediterranean, we're the last large-scale citrus regions free of HLB as far as we know. But Australia does have a diverse psyllid fauna and native citrus. So there is a question of potential for other psyllids to maybe vector HLB. Most of these cases, you're looking at sort of, they've evolved together, the bacterium and the psyllids. So there is quite a close relationship there, and it may not be passed on to other psyllids, but that is a question of potential there. So government surveillance around international ports and in Northern Australia is ongoing to monitor for early detection of the psyllids and the disease. But the citrus industry in Australia is also proactive. They've got a Citrus Watch program where they do trapping and plant sampling. I can probably promote it right now. I've just been today around Brisbane setting some of those insect traps, monitoring for those psyllids. And there's just a picture. This is Citrus Watch. So there's over 1,000 sticky traps being put out a year through an early detector network. And there's a lot of volunteers involved, as well as there's farmers and community gardens and all sorts that are involved in this. And so they're monitoring obviously for the two vectors of HLB. We've also got them monitoring the plants themselves, looking for those diseases. as well as vectors of other diseases like the Xylella. So for management, really we're looking at reduction in spread. Back in the 1950s, Chinese studies suggested using clean stock, removing infected plants, and insect suppression. So three parts. And unfortunately, due to lack of a cure so far, or breakthroughs due to this complex system, there's a high use of insecticides to try and control those psyllids, and that remains the main method. So it reduces secondary spread, but won't stop the primary infections. It's often frequently applied. So it's the cases where up to 52 sprays a year have failed in Southeast Asia and 40 sprays a year being performed in Brazil. Obviously, with that much use of insecticide, resistance pops up, and that was shown in Florida within 13 years of the psyllid getting there. Systemic treatments can reduce that frequency of the insecticide, so they're being used a bit, both trunk injection and soil treatments. And oils, insecticide, or soaps and kaolin clay offer some alternatives. The really important thing for using insecticide is optimizing those spray programs. So just doing it where and when it's best. So using IPM principles. So during flush events in particular, especially young trees. And really frequent monitoring is needed to keep on top of those numbers. So weekly inspections or trapping of psyllids. So management, it's still a three-pronged approach. Currently, it's removal of those infected trees, replaced with the uninfected trees, and psyllid control. And that's had really variable success. In China, they've had periods where it hasn't worked, but when they've been on top of it, for instance, they brought it down from about 20% to 4% incidence of HLB. Brazil tried as well. They had an incomplete removal of inoculum, and it went from a 2% to 20% of HLB. So Florida also, they did it on too small a scale with incomplete implementation, and it just didn't work. But modelling suggests if you had 100% implementation in theory, you'd be at 1% incidence of HLB. So it's definitely worth trying to keep all those three parts going. It needs to be done on a large scale, so area-wide management, and that requires coordinated spray programs, effective over a 5-kilometre area around orchards. And if you do it right, the cost can be quite low compared to the benefits that you get from it. But it needs to include non-commercial areas and protection of nursery trees. So in Florida, for example, they've moved their nursery trees from being virtually all outdoors to all indoors, and they delay field planting. And cultural practices to reduce psyllid entry into those orchards is really important, but neighbours are critical. You can't be doing all the best and then your neighbour's not doing the same. It won't work. For cultural practices, there's a lot of options. Barriers and windbreaks do have a big impact with fences and non-tree hosts. There's interfering visual clues used for psyllids, so kaolin sprays and reflective mulches. Intercropping and trap crops, so using trap and kill systems. Even guava deters feeding on neighbouring citrus. And if you combine those attractants and deterrents, you can get a push-pull strategy. And attract and kill devices are other options where you add other things to sticky traps or insecticides to make them more effective. Parasitoids have been very effective in some cases, particularly with high humidity and temperatures, but not always. There's been very big differences in their effectiveness. And just quickly, those pictures on the right are interesting. You can tell if you've got Asian citrus psyllid, you can quite easily tell which parasitoids you might have based on where they emerge from the nymph. So the Tamarixias come out of the thorax, whereas you get the hole in the abdomen if you've got the others. And the African citrus psyllid has some parasitoids as well. But the key thing is that there's different ecotypes present. So multiple trials and introductions are needed to fit local sites, or there's even some models done to predict where they might work. But most important as well is for these used in unmanaged citrus, such as abandoned orchards where they're not doing control otherwise. And entomopathogenic fungi are another option. There's already commercial strains out there that that can be used and are in some cases effective. But again, human conditions seem to help those get along. And finally, predators do play quite an important part there. And ant control is sometimes really key, because the psyllids producing that honeydew, the ants will protect that and stop the predators and the parasites. So just in summary, HLB is caused by 3 bacteria vectored by 2 psyllids. All are significant to the citrus industry. There's still no cure for HLB as of yet, so prevention is ideal. But being a complex system, it requires multiple actions. Monitoring is key to management, and you need to enforce IPDM principles, and it needs to be done on an area-wide scale. Grower awareness and cooperation is really important so that you get that buy-in. And for the future, well, the research is ongoing on a large scale, but as yet, there's no silver bullet for it. And that's it from me, I believe. Bunch of reference there for later, and some of those are some interesting review papers and quite recent.
Thanks, Luke. That's fantastic, and thanks, Shireen. Maybe Shireen and Luke, we're going to ask you some questions. Really very interesting, but you didn't leave on like the most enthusiastic note, and that there's no silver bullet, but that's true for almost every plant pest disease, unfortunately. Does require an integrated pest management approach and also area-wide management, and we're going to hear about some of the approaches in the field soon. But I'd like to ask a few questions, and we had a few here in our Q&A, and they're quite specific, and either Cherie or Luke, feel free to jump in, but any indication of the bacteria changing the behaviour of the vector? Several symbionts were found to change the behaviour of the vector. Do you know if that is happening?
I haven't read about that, but I wouldn't be surprised. I'd be actually surprised if it has no impact on the vector. Usually there is some influence there with those sorts of interactions.
Okay.
And so we're talking about the Librobacter. So the symbionts can be different, but yeah, I agree with Luke that often there is a negative impact on the vectors when they pick up pathogens like that. But I'm sure there's papers out there, but there's a lot of papers.
Yeah, for sure. Do you know if the bacteria transfers to the respective predators if they're eaten? And will bacteria survive in the feces? This is an interesting question. Thanks, Tom.
Yeah, I don't believe so. The bacterium, like, people can't culture it even when they want to. So I think it's very sensitive. And even that, like other psyllids, we don't know of any other psyllids being able to even pass it on. So I think the moment it's out of the insect, it's done.
Okay,
yeah.
Good, interesting question though. And here's another question. Same person: with climate change and rising average global temperature, will that be a factor to speed up the spreading of the vectors to new areas?
Potentially, yes. In some cases, the African citrus psyllid, in some places they're predicting it's actually has less potential because of the climate change. And one of those maps that I had was actually predicting it for, I think it was 2055 or something. So they're actually looking at predicting, assuming climate change, where those things might occur. So there's some interesting papers there, definitely in the reference, that they can have a look at for more detail. But yeah, it will influence and change some of those. But you've got 2 psyllids there with different climate requirements. So it will be interesting to see how that goes.
Yeah, excellent. And a question here, maybe Luke, you just mentioned at the end about, I guess, the importance of grower awareness. What are the things that work for actually working with growers to actually get them to monitor more? What have you found?
In Australia, we're not doing management, so it'd be more for the countries that are doing the management now for HLB. But from what I've read, you need that buy-in, and there's interesting, some of those papers as well talk about the communication with farmers. So in the US, they've actually got real-time updates of where pests are, what's being found, and even spraying. So they'll have real-time updates on where and when you should spray to coordinate those sorts of things. So yeah, if you can get them on board for that, and I would assume you'd be using the industry's contacts and influence to get that supported on a large scale. But it needs, some method, depending, obviously it's going to depend on the country and the culture as to how they do that. But you need that buy-in on a great scale, because otherwise you have, someone doing some pesticide treatment and another one next door not doing anything, and it's just not going to work. You just constantly get this reintroduction.
So that's a good question. So for the monitoring as well, that's a good point in that Australia, for example, it's not there yet. Are farmers still interested in monitoring and playing a part, or is it hard to get them to be involved proactively before the pest is actually there, or how do you get around that?
I believe so. Obviously, there'll be differences in opinion, but Citrus Australia, the citrus industry, as I said, was quite proactive. So they've got a lot of citrus farmers on board with that Citrus Watch program. So there is a lot of support, and I think most of the farmers are well aware of the risk and see what's happened overseas. So that's something they certainly don't want in Australia, and they'd be supportive to try and keep it at bay as long as possible.